Hi guys, in this video tutorial I am going to explain dynamic programming. In short I will call it DP. So what actually DP is? DP is an algorithm to solve particular set of problems by breaking it into sub-problems and storing the results of sub-problems to avoid computing the same results again. In order to solve a problem using dynamic programming, problem must have following two properties: optimal substructure and overlapping subproblems. A given problem has optimal substructure if optimal solution of the given problem can be obtained by using optimal solutions of its subproblems. When a recursive algorithm revisits the same problem over and over again, we say that the problem has overlapping subproblems. These two properties will become more clear when I will use the example. You may be familiar with the Fibonacci series. It is a sequence of numbers starting with 0 and 1, 1, 2, 3, 5 and so on, such that the nth term of the Fibonacci is the sum of the previous two terms. So first of all we will use this definition of Fibonacci to solve the problem using recursive algorithm. Here is the pseudocode for this recursive algorithm. For n is equal to 0 it returns 0, for n is equal to 1 it returns 1, else it will return the sum of the subproblems by using the definition of the Fibonacci, which is fib n minus 1 plus fib n minus 2. So as we can see here in picture which is a recursion tree of this solution, that to calculate the nth term of the Fibonacci, it recursively calls fn minus 1 and fn minus 2. Fn minus 1 further calls fn minus 2 and fn minus 3. Similarly, fn minus 2 calls fn minus 3 and fn minus 4. This go on as it is shown. So we can see here that it is calling the same problems again and again and computing. Like fn minus 2 is here is called twice, fn minus 3 is also called twice. So we can see here the overlapping subproblems, and as fib n is equal to fib n minus 1 plus fib n minus 2, we can see the optimal structure which is explained before as the property of dynamic programming. If we analyze this recursive algorithm, you will see that it is actually slow. We can see here the recursion tree for calculating the value of f6. As we can see here in the shaded part, that these are the solutions which are called twice or thrice, which are calculating the same subproblems again and again. So we keep calculating the same value over and over here in recursion solution. Now here is the table for the number of calls. The nth Fibonacci number calls the function in the recursion. For n is equal to 1, it calls simply returns 1. For n is equal to 2, f2 call f1 and f0, so total calls will be 3. And similarly for n is equal to 3, number of calls will be 5. So if we draw the graph for this, we will see that it will be exponential. So finally we can say that it is a terrible way to compute the Fibonacci numbers using this solution through recursion, because it does so much redundant computation. So complexity through direct recursion will be exponential in n, where n is for the nth Fibonacci number. Now we will solve the problem using DP by storing the partial solutions and sub-problems. There are two ways to store these values. First method is memoization and another is bottom-up approach. The most important reason why we use DP is that it removes redundant sub-problems and reduces the overall execution time and complexity of solving the problem. Memoization is very similar to recursive version with a similar modification that it looks into the lookup table. Here is the pseudo code using memoization. Lookup is an array which initially stores -1. Fib is an function to calculate the nth value of the Fibonacci using memoization. As we can see, this pseudocode is very similar to the recursion approach. The only difference is that it calculates the subproblems only once by storing the subproblems in the lookup table. What it does is that if it sees the values in the lookup table, if it gets the value in the lookup table, then it simply returns, otherwise it will compute it and stores it in the lookup table. So we can say that once the value for a subproblem is calculated, it is stored and never computed again. So it computes each value only once, so the complexity will be linear as each subproblem is calculated only once. Here is the pseudo code for bottom-up approach. In bottom-up approach, we store the values for the base cases. Like here, we are using the array to store the subproblems. In the 0th index, we are storing 0, and at the first index we are storing 1. These are the base values. Using these values, we will calculate the values for the further values and return the values in the end. So the complexity of bottom approach also will be linear, as we can see from the pseudo code. Here are the some steps to solve the DP problem. This is a practice problem. You should try this problem by yourself by pausing the video. After it, you can watch the solution. In this problem, if I take the sample input 2, then we can reach the second step by taking a step of size 1 2 times and taking a step of size 2 once. Similarly, for the other sample input, I have provided the sample output. So initially we are at 0th step. Let DP be the array to store the subproblems solutions. So for n is equal to 1, we can reach first step only from 0th step in a single way by taking step of size 1. So dp1 will be equal to dp0, that is equal to 1. Similarly, for n is equal to 2, we can reach to second step from 0th step in a single way by taking step of size 2. Also we can reach from first step in a single way by taking a step of size 1. So number of ways to reach second step will be is equal to number of ways to reach 0th step plus number of ways to reach first step. So dp2 is equal to dp0 plus dp1, that is equal to 2. Similarly, we can calculate the solution for n is equal to 3. We can reach to third step from 0th step, from first step and from second step. So number of ways to reach third step will be is equal to number of ways to reach 0th step plus number of ways to reach first step plus number of ways to reach second step. So dp3 will be equal to dp0 plus dp1 plus dp2. As we can see here, it will be equal to 1 plus 1 plus 2 is equal to 4. So number of ways will be 4 to reach step 3. Similarly, I have explained here the number of ways to reach step 4. Similarly, for n is equal to 5, we can solve as explained before. So finally, we can say that to reach nth step, number of ways will be equal to the sum of last 3 optimal subproblems. That is dpn is equal to dpn minus 1 plus dpn minus 2 plus dpn minus 3. Here is the pseudo code. As we can see here, function calculates the value to reach the step n. dp0, dp1, dp2 are the base cases which store the value to reach the step 0, to reach step 1 and to reach step 2, and the for loop computes the value to reach the further steps, and dpn returns the value to reach the step n after storing the previous values. This is here the solution we can see. So finally, here are some important points about dynamic programming. You can go through it, and here are some links where you can study further about dynamic programming and the references I have used here. And here are some practice problems. You can try this to gain confidence in solving dynamic programming problems.